Okay, it's about 1:30 and we can go ahead and get started. So this session today is going to be on Git, and this is the introduction to GitHub room. So if you, what I'll say is that if you've never used Git or you've heard of Git, but you're not like intimately familiar with it, or maybe you've used it a little bit, but you find it really confusing, this is probably the right room for you. If you've used Git and you basically know how to use it, but you're not really sure about how to collaborate with other people, or you want a more advanced tutorial, go ahead and go next door to Alder 103. I won't be offended if you leave now. That's basically what the setup today, though. We're going to be, I'm going to be basically assuming that you've maybe heard of Git, but you don't necessarily know much about it or what it's really good for. And, oh, I just lost my screen. Why did I lose my screen? Can people online still see my screen?
Yes, we can.
You can? Okay. Weird. Give me just a second.
You can still see it on Zoom.
Yeah, but I can't see it in the room. Is this table, right? No, this is the.
There.
Okay, it's back.
Yeah. It was a bit.
Thank you, Kelly. Okay, sorry about that. All right, so I'm basically going to run this assuming that you don't necessarily know very much about Git. I just want to stress that it's going to be really hard for me to watch the chat in the Slack room. Do put questions there. Kelly will interrupt me if need be to ask questions, but we can also hear you fine, Zoom people. Feel free to jump in and interrupt me. That's totally fine. Okay, so before I jump into actually using Git and everything, I just want to point out some materials that are already on the hub. If you go into the curriculum directory, there is a Git and GitHub directory for both this session and the next door session. And in here is just a bunch of markdown files. I think if you open these, they're going to look like markdown file, like you see the markdown code. But if you right click and go to open with, you can select a markdown preview, and that gives you like a nicely formatted version of these files. And I'm not going to be going through these files like line by line or anything like that. These are reference files for you to look at later after the lesson if you want to review or if you can't remember something. But these are just for your reference, and they kind of explain everything I'm going to talk about in probably a lot more words and more detail. So if you find yourself needing a bit of a review, there's those files there to look at for Git. Okay, so Git and GitHub are two kind of intrinsically tied tools. Git is the tool that actually we're going to be using today. GitHub is the website where Git synchronizes all of its code to, generally speaking. GitHub is not the only place you can synchronize code using Git. You can set up your own server and run GitHub server yourself. Most people don't do that, though. Pretty much everyone in academia, or at least almost everyone I work with, just uses GitHub, and that's just kind of something that's pretty universally accepted. And part of the reason people do that is because GitHub is free. As long as your repositories are public, or you have fewer than, I think, 6 private repositories, your account is free. And you all have GitHub because we use GitHub to authenticate for this Jupyter Hub. So what I want you to do to start out this whole session is just go ahead and go to github.com and make sure you are logged in. Now I can tell I'm logged in because my profile picture is up here in the upper right. But if you're not logged in, go ahead and log in. We're going to need to do that in a minute anyway. Now, I'm going to be showing you how to use the command line for Git for the most part, but I also want to just mention that almost everything we're going to do on the command line can be done on the GitHub webpage. It's just not necessarily as convenient or I mean, often, as is the case with a command line tool versus a graphical tool, there are things you can do more easily in the command line and things you can do more easily in the website, and we can kind of talk about that as we go. Okay, so this is a command line tool, so we're not going to be using a Python notebook. Instead, we're going to start a terminal. So go ahead and if you don't have this launcher open, click this big blue plus button and then select the terminal button. And you should get a prompt something like this. I'm going to make this just a little bit bigger. And I'm going to collapse this sidebar since we won't really need it. Is that big enough that everyone can see this okay? Okay, great. Okay, so the first thing, we'll just start by typing git dash v. That should give you a Git version. Now, when I normally teach this this lesson, this is where we find out if people actually followed the instructions and installed Git ahead of time. But since we're all in this Jupyter Hub environment, you've all got Git running. So if this didn't work, then you've got problems that I don't know how to solve. But hopefully this worked for everyone. The first thing we need to do before we actually do very much with Git is configure it to know who we are on GitHub, what our name is, how we're going to use it, that kind of thing. So we're going to start out by running a bunch of commands, and you aren't going to have to run these again for this for the Jupyter Hub. Once you've run them once, they'll be kind of configured in GitHub and they'll be permanent. If you need to use Git on your own laptop in the future, you can run these same commands on your laptop and that'll configure your laptop, and then you won't have to run them again on your laptop. But every time you set up a new computer that accesses Git, you kind of have to set it up and configure it. So we're just going to do some of that together. Now these instructions, what I'm going to do now are also in that shared info directory. There's a Git setup file there that you can look at to follow these instructions on your own later. But we're just going to do them together right now. So we're going to use the git command. Git is a great big piece of software, and so it has many subcommands. So we're going to use the git config subcommand. And in particular, you can use git config to configure the way that Git handles a single repository, what's called a GitHub repository, which is what you store files and code and stuff in. Or you can configure it to work for all repositories you might have or might be using, which is what we're going to do. So we're going to say git config -- global, meaning we're going to do this configuration for every repository we use on this system. And we're going to start with a variable called user.name. And then in quotes, just put your name. This doesn't need to be your username. This just needs to be your name. And Git will use that to kind of sign commits and things. Then we'll talk about that in a little bit. After running that, we're going to do another one. We're going to say git config -- global user.email. And then again, in quotes, whatever email address you use to sign up for GitHub. So if in my case, I actually signed up for GitHub long before I came to the University of Washington, so I didn't use my UW email address. So I have to use this email address, anna@ben.net. But you should use whatever email address you signed up for Git with. Okay. So we also want to tell git config -- global. We're going to tell it what kind of editor we like to use. So I believe this is core.editor is the name of the, just double check that in my notes. Yeah, core.editor. Now, if you are someone who uses Linux or Unix pretty often and you know what your favorite editor is, if you, for example, know that you like Emacs or Vim or something, put that here. If none of that made sense to you, what you want to put is Nano. Nano is a very simple text editor that runs in the terminal, and I'll be using Nano for this example, and we'll use that. It's very easy to use. Okay. Great. So we can now look at all the configuration items we've set with git config -- list. Now there's a couple things here. These credentials, don't worry about that. We'll set that up in just a second. But you can see my username and user email here. And here is one that I actually forgot, but we need to run as well. So that was useful. We'll say git config dash dash global poll.ff only. I will talk about what that means a little later. That has to, the poll.ff configuration item is basically telling Git about what it should do when it's trying to resolve different changes to the same file from different people. So if we're working on a file together and I change it and check in some data and you change it and check in some data, Git will say something like, I'm confused, I don't know how to resolve this. And this is telling it a little about what strategy to use. We'll talk about this a little later. Okay, so we've now told Git kind of who we are and a little bit about how we're going to use it, but we haven't told Git anything about how to talk to GitHub or who we are on GitHub necessarily. So the next thing we need to do is we need to set up a way to talk to GitHub securely. So pretty much all secure communication on the internet these days is done by what's called public key encryption. Public key encryption involves a bunch of very fancy math and prime numbers, and the basic idea behind it, well, I'm not going to try to explain the math, I don't really understand it, but the basic idea behind public key encryption is that I can generate a pair of really big numbers. One of them is my public key, and one of them is my private key. And I can publish my public key, and you can take that public key and take any message you want to send me. And by doing some fancy power math and taking some modulus operations, you can end up with a number that is encrypted, where it basically represents the message you wanted to send me, but you've encrypted it using my public key. And what's great about that is that you can publish that to the world, and only someone who has my private key can decrypt it. So by performing these operations, you end up with a message that only I can read, and I can give everyone my public key because all that lets them do is send me private messages. At the same time, I can do a similar kind of set of math with my private key, where I can make a message and I can publish it to the world, and you can take my public key and you can decrypt it. And what's useful about that is that the only person who could have made that message is someone who had my private key. So I can send messages to you, to anyone really, that everyone knows have to be from me. And you can encrypt messages such that only I can read the contents. And if you can do that, if two people can do that, then we can talk to each other securely without anyone being able to know what we're saying by publishing our public keys to the world. If that doesn't make sense, that's okay. That's the basic theory behind this. We're not going to need to know the theory. I'm just kind of telling you because I think it's interesting. But what we're going to do next is we're going to actually generate a public and private key. Now I'm going to run a command real quick so that this works the same way you did, because I set this up earlier. Ignore this command real quick. Wait, don't do that command. For all of you, what you want to run right now is this next command. It's ssh-keygen space -C, and then put your email address in quotes. Use whatever email address you used up here. So I'm going to put n@nben.net. And then -t space ed25519. ed25519 is the name of an algorithm that generates public and private keys. I don't know what its significance is aside from that, but that's why we're putting it there. You can go ahead and push enter, and it's going to ask you a few questions. The first one is, where do you want to save this? What it's prompting you is perfectly fine. You can just push enter there. The next thing it's going to ask you is for a passphrase. And while you might intuit that you would want to put a passphrase on your public and private key, we're actually going to leave this blank because the only people who have access to these public and private keys are you. I don't even have access to the instance of Jupyter you're running. So this is perfectly safe. You can just put no password. If you did put a password, everything would still work. It's just that every time we tried to talk to GitHub, it would ask you for that password. And this way we can just enter our Git commands and not have to type a password every time. Okay, now it's going to print out this little bit of ASCII text here, or ASCII art. This has something to do with the random number that it used to generate your public key. I don't really understand it myself, but it'll be different for all of you. It won't look the same. At least it should be different for all of you. Yeah. Great question. Is the public key linked to your account or to your computer? The public key only exists right now in a file that just got written out on this cloud computer. Yeah. So this is really, this is just generating a pair of big prime numbers. That's what you just did. And those can be turned into public and private keys. So if I now type ls, real quick, can I have a show of hands? Who knows enough Bash to know what ls means? Oh, good. Okay. So ls is just like a list of the contents of a file. I'm going to say ls tilde slash dot ssh. And just to emphasize that tilde is not a hyphen, that is the little squiggly line that's usually above your tab key. That stands for your home directory. And inside of this .ssh directory, I've got an ID ed25519 and an ID ed25519.pub file. This is the private key, and the pub file is the public key. And so what we want to type next is cat, which just prints a file to the screen. And then we're going to say tilde slash .ssh slash ID underscore ed25519.pub. Make sure you print the pub one. I'm going to go ahead and show you the contents of this because it's perfectly safe for me to show you the contents of my public key. That won't affect anything. It won't let you log into my account or anything. So what this basically says is this is the kind of key we've made. This is the public key itself, this kind of line of random text. That's a kind of strange representation of a really big number using digits, including letters. So anyway, this basically that all represents my public key. And then it's got my email address. So what we're going to do is we're going to take this whole line, oops, starting with the SSH and ending with your email address, and we're going to copy it. So for me, that's Command C. If you're on Windows, I assume it's Control C. I'm actually haven't used Windows in like 15 years, but I trust you all know how to copy it. You can probably also right click and copy this way. So this is our public key, and we need to take this back to github.com. So go back to the tab where you logged into GitHub. And I'll just make this a little bigger. What we're going to do is go to the upper right where you've got a little user icon. For me, it's my face. For some of you, it will probably be something different. And if you click there, you'll get this menu. And you can go down to settings, the gear icon. So I'll give you all a second to find that. Once you've gone to settings, you should see something kind of like this. And over on the left, about halfway down this menu on the left, should be SSH and GPG keys. We're going to click on that next. Now, you may not have any of these, or you will not have the same ones as I do. But all we need to do here is click this big green new SSH key button. And that'll bring up a prompt where we can add this SSH key. And for title, I would just call it Neuroacademy Jupyter Hub Server, or something like that. This is just a name for you to remember it by. This doesn't really matter that much, just so long as you can tell what key this is. And then down here in the key, you just paste that line that you copied. And if you've got something like this, make sure it has this SSH-ed25519 at the front and it has your email address at the end. But if you've got that in there, you can just go ahead and push add SSH key. Here it's asking me to verify my identity, which I will do. There we go. And then you should be able to see that key in this list, so I can see it here.
Could you please go back to the terminal? So I didn't get how we got the link. Okay.
We didn't get a, you mean, you didn't get how we
yes.
got?
Yeah.
Yeah, so for that, we ran this command here, this SSH-keygen, and then $C, and then your email address in quotes, and then -T ed25519. Kelly, maybe you could copy and paste that into the Slack channel just so they can.
And what does CAT stand for?
CAT stands for concatenate. It just prints a file to the screen. That's all it does.
Okay.
So yeah, this particular file here, its contents are just this line by itself. Sorry, Leah, I think I can't hear you.
Can you hear me?
Just barely.
Sorry, I'm currently in a public place. I'm talking extremely loudly, but I got an error saying that my key is invalid when I just copied over that line of text.
You got an error saying your key isn't valid? Is that what you said?
It says error key is invalid.
Sorry, you're very difficult to hear. I realize you're talking loudly, but perhaps are you able to put a message in Slack? It might be easier to debug over Slack. Since we can't really hear you. Sorry. I think you said that you got a key is invalid error. So if you copied this from the terminal and you got a key is invalid error, my guess is that you might have accidentally like not copied the first S or something like that on the SSH. If you're missing a few characters in the front, it will say something like key is invalid. I would suggest trying to debug that over Slack if possible, or put a message in Slack so that we can see what's going on. Okay, anyone else getting errors? Because this part, we want everyone to be able to do this part so that they can use Git on the hub. Yeah.
Yeah, sorry, but let's say I put the piece SSH dash keys in. It says that it's generating here, and it says enter file, just like it says for you.
Yep.
Then it's passphrase. I'm trying to like this what to do. I just
Yeah. Right. So when it prompts you for the passphrase, just push enter twice. You don't need to put a password there because these keys are secure on the server already. Yeah, no problem. Okay. Any other issues from okay. Okay. I guess now is a good time to let you know that every year at Neurohack Academy we have a lot of issues with Git, not because of well, I mean, it is because of Git, because Git is a really big, complicated piece of software that's designed to handle giant projects by big corporations and things like that. So Git can do a lot of things and it can be very confusing as a result. And so pretty much every year we have people who struggle a little with Git. And so this year we've decided that in week 2, we're going to have what's called a Git clinic, where in the morning you can basically come to us with Git problems and we'll try to diagnose them with you. Typically, Git problems can be very weird, and if you've just done it enough, it can be kind of obvious what's going on. So I would encourage you, if you end up at some point, especially in week 2, struggling to get something to work in Git, come talk to us. We can usually help you figure it out. And that includes authenticating if you have trouble with this now and need help later. Okay. At this point, I'm going to assume we've managed to get all that set up. So I'm going to step back a little bit and talk just kind of about what Git is supposed to be for and how we typically use it. The basic idea of Git, you've probably all at this point, there was a time when I taught Git when Google Docs existed, but people hadn't really used it yet. And there was this very common thing where you would be working on a paper with your professor and you would have a Word document and you would edit it and you would send it to or maybe you'd print it out and give it to your professor and they would give you back something with a bunch of red ink. And then you would make changes and then you give it to someone else and they would give you multiple people who are collaborating on it would give you different copies and you would end up merging all these together. And it can very quickly get very difficult to remember which copies are original, which copies have changes from a particular version. That all gets very difficult to track very quickly. Git is designed to solve that problem and a few other problems. And in particular, it's made for source code. Now you can use it to write papers and documents, but it just doesn't work as well when the files you're tracking aren't basically text files like code files. It's really made to track simple text and changes to simple text. Now there's really 2 big problems the way I see it that Git solves. One is collaborating with other people and merging changes and tracking changes and who's changed what. And also having all that backed up and synchronized. The other thing it is really good for is that when you do things in Git, it keeps track of every change you've made. It doesn't just keep track of the state of your files right now. It keeps track of every change from when you started the repository up to the current state. So if you at some point are like, oh, wow, right before I published that paper, I introduced a bug, I need to go back and see the state of the repository on January 1st of 2016 or whatever, you can do that with Git. You can basically say, roll me back to wherever this was, and it will tell you exactly what the files were like at that point in time. So in software, this becomes very important. And both of these problems become very important. And so Git is a tool that kind of lets us manage that. Okay, so that said, what we're going to work on today is not going to be source code, because I don't want us really thinking about source code specifically today. Instead, we're going to be working on recipes together. So rather than write like a Python file, we're going to write a repository that tracks some recipes. So there are multiple ways to create a repository, but we're going to do it by the way that almost everyone does it, which is by going to github.com. So go ahead and go back to your tab here. And go ahead and click this this Octocat icon to take you back to the main page. Now your home page is not going to look exactly like mine, but you should have a new button here. You should also have a plus button with a drop down up here. I'm going to create a repository using this button. If you click this plus drop down, you can click this new repository. We're going to basically leave most of this the way it is, but we're going to give it a name. Of course, last time I taught this class, I made a repository called recipes, so I can't do that. So instead, we're going to call this cookbook. Oh no, I did that last time too. Okay, well, I'm going to call it cookbook 2. You all can call it cookbook. I'll just have to remember to remind you that when I say cookbook 2, you have to type cookbook. All right, we can put a little description here. I'm just going to say this is a repository of recipes. We're going to leave it public. In general, I do pretty much all of my work in public on GitHub, and I think you can have up to like 6 private repositories without paying for a GitHub membership. But in general, I suggest working in public, partly because in the future, when you apply to like the eScience Institute for a job or to the psychology department for a faculty position, we're going to go look at your GitHub. And if there's nothing there, we're going to really wonder whether you have ever done any programming before. And if there are repositories that you feel like are in a poor state, we're going to understand that, because we also use GitHub and write code and know that repositories are usually in a kind of poor state. And aren't always as well documented as we want. And we'll be able to look at that and say, oh, but this person actually can code. Whereas if you've got nothing, we've got nothing. So my advice is to always work in public unless you really have some reason you can't, like you're working with, I don't know, you're working with a collaborator who like refuses to is worried about getting scooped or something like that. I think it's debatable whether that's a good enough reason, but regardless, my point is just work in public if you can. It'll help your careers and resumes and that kind of thing. Okay, we're going to go ahead and add a README file. README files are just information about the repository, nothing fancy. We'll look at that in a minute. We can choose a license here if we want. I usually use the MIT license for my code. This isn't something we talk about a lot in this course, but there's various kinds of open licenses. I'm just going to use MIT for this one. Okay. Once you've kind of set those, go ahead and click Create Repository. And what this does is it takes you to the page for this repository. Now, if you look at the web address, it should be github.com/your username, and for me that's Noah Benson, /cookbook, or for me cookbook 2. That's where you can find this repository. That's basically its address. We'll see that in just a minute. And you should see this license in README, assuming you picked the same things I did. And you notice that the description that we gave is down here in the README already for us. Okay, so we've made a repository and we've made it on github.com. But now what we want to do is we want to actually be able to work in that repository. So we're going to go back over to our terminal. I'm going to type CD just to make sure I'm in my home directory by itself. And then I'm going to enter our first like real Git command, git clone, which will clone a repository. It will go find a repository on github.com and clone it for us. Git at github.com : this is just how you start all the GitHub repositories you want to clone. They always start with git at github.com : and then you're going to put your username. For me, that's Noah Benson, / and then your repository. So for all of you, it should be cookbook. For me, it's cookbook 2, like that. And then press enter. Now, the first thing it's going to do is it's going to give you this question that says, basically, I'm connecting to this host called github.com. I don't know what github.com is. It gave me a public key. Do you trust that this is GitHub's actual public key, or is this maybe someone else pretending to be GitHub? That's basically what it's asking us here. You can just say yes, this is fine. It won't ask you that question again. Okay, so what did that actually do? If I type ls now, there's the directories that were previously here, but there's a cookbook 2 directory here for me now. Cookbook for most of you probably. So I'm just going to cd into that directory. And if I type ls in this directory, we can see that license and that README file that we saw earlier. Yeah. You forgot to add the what? Okay. Well, yes, the answer is yes. We're just, in fact, all that we're going to be doing for the rest of this course, this session, is editing the repository. But so let's suppose you forgot to add the license as an example. What you can do is type nano, which is our text editor, and then license. Now, this text, I don't want you to have to like write this all out, type it all out right here. But basically, why don't you just put like MIT license as the first line, and then let's see. I'm going to let's see, what's a good edit to add here? Well, I'm going for yeah, we don't really want to change this file because it contains legal text. So this is maybe not the best example, but you could put MIT license as the first line of yours, and then push Control-O to save out the file that you've edited, and then push Control-X to get out of nano. For the rest of us, we'll edit a different file instead of license. So go ahead next and type nano readme.md. So that's the README file we had it automatically create. And this is the contents. Now, this is a markdown file. Markdown is basically a way of kind of writing web pages without all the crazy HTML formatting. For example, this first line is a £, then cookbook, or cookbook 2 for me. And the £, basically means this is a header 1, this is a title. And then this is just normal text below it. So I think this is fine. We have a cookbook. This is a repository of recipes. I'm going to add a couple blank, like a blank line here, and then say table of contents. 1, guacamole. That's going to be the first recipe we're going to write is going to be a guacamole recipe. So we've added this to the table of contents here in our README file now. So I want to save this change. In the nano editor, we push Control-O to write out the file, and then push enter. It's saying is readme.md okay as a file name. Just push enter, and then Control-X to exit out of the README. Yeah.
There's a question in Slack that says, is there a downside to using git add dot on the project root directory as long as there is a properly specified .git ignore? Also, can you share some best practices around the scope of commits, i.e. how often to make them when working on a project?
Yes, we'll get to the commits question. As far as the git add, we'll get to that in a second too, but the quick answer is yes, there are downsides. You might add something you don't realize has been edited, but otherwise, if your git ignore is good enough, probably not. But we'll talk about that. Yeah. Okay, so we've made an edit to this README file. If we now type the command git status, it'll tell us pretty much. It says we're on branch main. That just means we'll talk about branches in a little bit here. That's a normal thing for it to say. But down here it says there are changes not staged for commit. You have modified this readme.md file. So Git clearly knows that we've made a change. Now I didn't change the license file, and it didn't tell me the license file has changed. So it also knows that I haven't changed the license file. So git status can tell you that. We'll deal with that change in just a minute. But before we do that, we're going to actually write this guacamole recipe. So let's go ahead and run nano guacamole.txt. Yeah.
I didn't understand how to exit the the text.
Yeah, so if you're in nano readme like this in here, there's actually at the bottom here, there's a little legend that's a little tricky to read, but this $O stands for Control O. So you hold down Control and push the O button, and that will save it. You can push Enter here, and then the Control X will exit. So Control and then push X should exit out. Does that work?
No, I think I did something wrong, but don't worry, you can go ahead.
Okay. If you're stuck in nano, I think you can push Control. No, yeah, push Control T, Control Z. That should suspend it. But if you're stuck in nano somehow, you can also just open up a new terminal and start over that way.
Okay, thank you.
Okay, yeah.
And I have a question also, if you don't mind. So when I opened the readme.md, I did not find like the sentence, this is a repository of recipes. So why is this?
So that's probably because when you created the repository, there was a box for a description. And whatever you put in that description is what it will put in the README file initially. So I put a repository for recipes in that box. If you didn't fill it out, then it wouldn't have had anything. Yeah.
I actually did the same. And that's why I just confused. Yeah. Yeah,
I'm not sure why that would have been. But regardless, you should be able to add that line if you want. And I don't know, if you see other things weird like that, let me know. But probably that was just some hiccup in the process.
And when I access the README online from like GitHub, I see the phrase. So I see it.
You do see it here.
Yeah.
But when you cloned it, you didn't see it?
Yeah.
How about if you just type cat readme.md like that? What's read.md?
Oh.
I had the same thing happen to me, but it was because I didn't capitalize README. So it created a different text file for me. So I don't know if the same problem, if I capitalize it, then it comes up.
Yeah, so Unix and Linux are case sensitive in the file system. If you cat readme.md, that's going to say there's no such file because it cares about capitalization. Yeah, so lowercase readme is different than uppercase readme.
Yeah, okay, thank you.
Yep. Okay. All right, so we're going to edit this guacamole. Guacamole.md. Okay, so we've got a blank file here, guacamole.md. And I'm going to start by saying ingredients. I'm going to make a bulleted list with little stars or little asterisks. We of course need avocados, onions, cilantro, salt, lime. You might want other things in your guacamole. That's fine. You don't have to make exactly the same recipe as me. Instructions. And I'm going to have a real simple recipe. Mix everything together, mash it up. Again, you don't have to have the exact same guacamole recipe as me, but I'm going to go ahead and say this is good enough. I'm going to push Control and then O to write this out, and then Enter because guacamole.md is fine. And then I'm going to push Control and X to exit out of new. Okay. So I'm going to run that git status command again, and then I'll pause and make sure everyone's caught up. But once I run git status, you can see that it's saying you still have this README file that you've modified. You've also got this new file that is not tracked. It's not anything that Git knows about. And that's what it's saying there. Okay, everyone caught up? Did anyone have trouble with the nano or any of that?
Sorry, can I ask a question?
Yeah, of course.
Let me just put the camera on so that you can see my face.
Oh,
So
I can't see you anyway, but go ahead.
Oh, that's okay. Just to add a human element to it. So when I run this, I actually get Fatal, not a Git repository.
Are
Stop.
you in your cookbook directory? You might have forgotten to move CD into the cookbook directory. So
That's fine. Let me see.
If you type pwd, it'll tell you what directory you're in. And
Yeah.
it should be home Jovian and then the name of your repository, like cookbook or cookbook 2 for me.
Right. So no, it's just home and then /Jovian.
Okay, so go ahead and just do cd space cookbook and see if that works. And if I'm assuming you made the guacamole.md file already.
I did.
Yeah, so if did cd cookbook work?
Actually, no, because then when I print the working directory, it's still home Jovian.
Okay, if you
I'm not
type
sure why.
ls, did it give you an error about like can't change the directory?
Does it readme shared? That's what it tells me when I run ls. Curriculum fleeting A, which is my tag on GitHub.
When you type cd space cookbook and run that command, what does it say?
Bear with me. No such file or directory.
Okay, when you ran git clone, whoops. When you ran this command, and then your username /cookbook. Let's see if I scroll up, I can probably find that. You should have gotten output that's kind of like this.
Let me see again. Git at github.com and then right, okay. I'm gonna try again.
Okay.
Maybe I added a space or something.
Yeah, my guess is that it just didn't clone correctly.
Maybe.
Okay.
Now cloning into it. Yeah, maybe I added a space or something. Should be fine now.
Okay.
Thank you.
All right. So we have this README file we've modified, and we have this new file that we've added. And what Git is telling us is that it doesn't know about these files yet. Or rather, it knows about the README file, but we've changed it. And it says that this is not staged for commit. So what does this actually mean? Well, Git kind of assumes that you're going to do a bunch of work in multiple files. Like if you're working on a big repository with a lot of code files in it, those code files are going to interact with each other. Some of the functions in one code file are going to be called in another code file. So typically, when you make a change to a code repository, you're going to change several files. And you don't necessarily want Git to record every little change you make. You want to put them all together as like, here's a package change. It's these 4 files have been changed and they all work together, and now I'm committing those. That's the basic idea. So in like Google Docs, it tracks every little keystroke you make. This is more like, you don't want everyone to see every keystroke. This is, you want everyone to see the final finished change. So what we need to do is we need to tell Git, first of all, that we've worked on a file, and we're going to add a bunch of files to what's called the staging area. So we'll do that first. Git add readme.md. Okay. It doesn't print any output. Typically in Unix and Linux, if it doesn't print any output, a command ran just fine. And then we'll just go ahead and type git status. And you'll notice that it still has this message about an untracked guacamole.md file. But it now says there's a change to be committed here, which is the readme.md. So we still haven't committed this. And the reason is because we want to commit more than just this one file. We not only changed the README to say that there's a guacamole recipe, we added the guacamole recipe. And if we committed it right now, we'd have a README that says there's a guacamole recipe, but no recipe. So we're going to also git add guacamole.md. Now, if I type git status, it'll say we have a modified README and a new file, and these are to be committed. Okay, so that's how we put things in the staging area. You can take things out of the staging area if you put them in there by accident, or if you decide you need to work on them a little more. I'm just going to show you this command. I have almost never used it in my whole life, to be honest, but it is possible. The command is git restore -- staged, and then you could say like readme.md, and it would take the readme out of the staging area and back to where you're editing it. However, I'm not going to run this because we don't need to run it. If you do run it, just add it back in. Okay, so we've got these changes. Now we're ready to commit the changes. So we're just going to use the git commit command, and that'll commit everything in the staging area. Now, what actually happened here when I ran that was it opened up Nano. And basically what it's saying is, okay, we're putting together a commit. Give me a log message about what this commit is about. So I'm just going to have a simple message here, adding the first recipe guacamole. Typically, when you make a commit, if you're making a commit to like an open source project or something that's like part of a research project, you'd want to give a nice description of enough that people know what this commit is about and what you were doing. I'm just going to make a fairly simple message for this one. And then I'm going to push Control O again to write it out. And then Control X to exit out of there. And it prints this little message here. 2 files changed, some number of insertions, this create mode thing. This is basically just telling us a little bit of technical information about the commit that was just made. And now if we type git status, it says on branch main, nothing to commit, working tree clean. And there's a message here, which I'll get to in just a minute. But at this point, we have taken those little changes we made to those 2 files, and we've made them part of the repository for the cookbook. So those are permanently now part of the cookbook's history, or part of the commit log of this cookbook. And while there are ways to delete them, that is generally strongly frowned upon. You don't typically delete things out of GitHub repositories, but we'll get to that in a little bit here. Okay, so let's go back to github.com. And since we committed, you might expect that if we refreshed, we would see those changes, but we don't. And there's a good reason for that. GitHub.com is a website that stores your repository and is a place you can sync your repository and other people can clone it and check it out. It's sort of like home base for your repository. When you cloned the repository onto your local computer, you made a copy of it as it was at the time when you cloned it. But when we committed, all we did was we committed into that copy of the repository on our computer. We didn't tell Git to do anything about talking to GitHub. So that takes one more command, and that command is git push. Git push tells Git to basically go connect to github.com and tell it about everything we've done since last time we talked to GitHub. So when I run this, it'll give me this message about counting objects and stuff. But typically you can more or less ignore these as long as it doesn't give you an error. But after running this, we can go back to github.com. And if I reload this now, we'll see that there's now guacamole.md here. And if you look in the README, there's a guacamole entry. Okay. Everyone, so far so good? Any questions? Okay. All right, I'm gonna jump ahead a little bit here and do something slightly different. Everything we can do on the command line, or almost everything, we can also do in this website. And some people prefer to work in the website, and that's fine. I typically think it's fine to do little things in the website, but if you're like doing a bunch of coding, you often want to do it in your own editor and not in like a web browser editor. But I just want to show you that this is all possible. So if you go ahead and click on one of these files, like let's take guacamole.md, it'll give you like a sort of preview of it, or a different version of it. And you'll notice that there's a little edit button over here in the upper right. If you click this edit button, you'll actually get an editor here. And I'm just going to make a small change. I'm going to say mash it up with a fork. Okay. once I've made that edit, there's a big green commit changes button up here. I can just go ahead and click that, and it'll give me a little place I can type a commit message. I'm going to say noted that should match with the fork. So I'm just going to have a simple commit message there. And I'm going to commit those changes. And now if I click back over here, and once again, open up the guacamole.md, you can see that that change is clearly there. So we just made a change to the repository on github.com by using the web editor. And pretty much that was exactly the same as using the browser locally. We just did it in, or using our terminal locally, we just did it in the browser. Okay. So now if we go back to the terminal, and I'm just going to cat guacamole.md, and we can say that that change is not here. And that's because, of course, once again, Git doesn't automatically talk to GitHub. You have to tell it to talk to GitHub for it to sync things. So if we want to tell Git to go ahead and sync the repository that we have locally with any changes up on the github.com website, we can use the opposite of git push, which is git pull. So when we type git pull, this will go ahead and run, and it has this little message about fast forwarding, and it's made a little change to guacamole.md. And now if we cat guacamole.md, we'll see that that mix it up with a fork is right there. Okay, yes.
Is there a way to, I guess the reason we don't have to specify
You're saying we don't have to specify what we're pulling because we're. So are you getting at like having to set an upstream? Is that having to set an up, like depending on how you set up your GitHub repository locally, sometimes you have to tell GitHub where to, or tell it where to go connect. So if you there's kind of an alternate workflow here, and so to explain really quickly, what we did was we went ahead and set up a repository on github.com, and then we cloned it. And since we cloned it, Git knew that that came from github.com because we told it so. So when we push and pull, it knows to go connect to github.com. If there's another way you could have done this where we had made the directory and then run git init to initialize a repository, and then you have to tell it, oh, by the way, I want this to be synced up to GitHub. And I think that is maybe what you're getting at. Yeah, okay. Yeah, in our case, we didn't have to tell it because we cloned it from GitHub, so it knew it was from GitHub. Yeah. And the question online? Yeah.
Just curious, how does GitHub make sure that nobody else is able to edit and push to my repositories?
Great question. Okay, so an easy way to demo that, go ahead and cd space ... and then try to clone my repository. So if you type git clone git at github.com : and now I'm gonna pick out some repository I know about.
I think it will ask for credentials or something.
Yes. So if you put in someone else's repository here, it's going to say, hey, you don't have permission. You're logging in as your user. And it knows that because we gave it an SSH key from our account here. So it knows who you are. It's using that SSH key to authenticate you. So when you go try to clone someone else's repository, it'll basically say, oh, you can't clone this. This is someone else's repository. Same thing with if you go into the website and I go to one of your cookbook repositories and I try to click this edit button, it's going to say like, you can't edit this. This isn't your repository. You don't have permission. So GitHub manages all the authentication and stuff for us. Yeah.
How does it know where your private key is?
How does it know where our private key is? So it doesn't know where our private key is. What it knows is what our public key is. And when we connect via SSH to it, we basically GitHub. How does this work exactly? We use so basically Git will take our private key and make a little message saying, here's the email address I have on file, and I've authenticated it with my private key so that anyone can read it, but only I could have written it. GitHub gets that, and since we gave it the public key, it takes that public key and decrypts the message and sees, oh, here's the email address I'm expecting, so this has to be the person who's connecting. Does that make sense?
Yeah, so it just checks the status of it.
Yeah, yeah. Git is smart enough to go look up that private key that we made and use it, basically. Yeah. Great question, though. Okay, other questions? Okay. All right, so let's so right there we've just gone over git add, git commit, we've git clone, we made a repository online, we did git push, git pull. That is 95% of all the Git you really need to know to use Git. What gets tricky a lot of times is that multiple people can be using a repository simultaneously. So when I go over to github.com, in this repository, there is a settings tab for this repository. And you don't need to do this with me, but you can go over here and there's a collaborators tab where you can say, oh, I want to add people who also can edit this repository. So if I wanted all of you to work on this repository with me, I just add you as collaborators, and then you could all check out this repository and push to it and all that stuff as if it was your repository. What that means is that I may have the repository checked out and I may be working on one file, like I may be editing this guacamole recipe while you're off somewhere else editing a different file. And then we both update the table of contents in the README file. And then we have a situation where our README files are out of sync. Git helps a lot with this, and that's mostly what they're talking about next door. We'll see how far we get. We may talk a little bit about merges and how to handle this kind of situation. But for now, we're going to start a little simpler. We're going to talk about the git log command. So remember I said that Git tracks all of the changes you make starting from the initial condition of the repository. So it's not just saving the current state of the files, it's saving all the updates you've made. If you type git log, it'll just give you a list of every change you've made. And in our case, there's only 3. Starting at the very beginning, there was an initial commit, which was kind of what started the repository at the very beginning. This is when we set up the repository in github.com. And then we have the commit we made where we added the first recipe, guacamole. And then we have the commit we made where on github.com, where we said you need to mash it with a fork. And notice that even it doesn't matter where I made the commit, whether I did it in the terminal or whether I did it on github.com, the point is they were all changes to this repository, and so they all go into the log. And they're ordered because this commit was made to the repository at this state, and this commit was made to the repository at this state. If you have 2 people editing, they may not be ordered anymore. They may have been simultaneous, but if we get to that, we'll get to that. You can also type git log -- one line, and that just gives you a condensed version of that same message, where it prints each commit as just one line with the message here. Now, there's a bunch of extra stuff in this message that I haven't really talked about. First of all, there's these great big strings that are just kind of look like junk. Those are actually unique identifiers for every commit. Every commit in GitHub has a unique identifier, and you can use these to reference a particular commit if you need to. There's also this this stuff about head. And I'm going to see if I can. I'm going to see if everyone can see this if I use the annotation tool real quick. People online, can you see that squiggle I just drew?
Yeah, we can see it.
Yes.
Yep.
Great, thank you. Okay, perfect, that'll work. Okay, so when we started the repository, there was an initial commit, which I'm going to represent as this dot. And then we made a commit, which was the changes, adding the guacamole, which I'm representing as this line, basically. So this line brought the initial state of the repository forward to another state. And then we made another commit. This is the match it with a fork commit that brings it to another state. And as we add commits to our GitHub repository, it basically builds up this sort of very simple tree or graph of the commits as we go. And what often happens is at some point, we've been working on this like a library for a long time, and we're ready to publish it as version 1. Okay, so we're going to say this right here. This is version 1. Okay, but then we're going to keep working on it. We're going to start working on version 2, and so we make some more commits, and we make some more commits, and we start adding features, right? somewhere down the road, we're going to have a library that's ready to be version 2, but we're not there yet. In the meantime, we find out that there's a bug in version 1. We find that we need to fix something. So we've already started working on version 2 over here. So we've changed things about this library that we don't want to be part of version 1. But we do want to add another commit that is basically fix version 1 over here. So now we have a graph that's not just a straight line. It's not just adding one commit forward and forward. It's we've got a branch where we've gone from version 1 to version 1 fixed, and these towards version 2. Am I making sense so far? Okay, good. Git handles this situation very elegantly. Basically, when we made this repository, we made what was called the main branch of the repository. And whenever we add a commit, Git updates what's called the head of the main branch to point at the newest commit. So when we added our 2 commits, the head of our main branch kind of points to this commit. If we want to then start working on version 2 of the library, we can make a new branch that also points to this point, and we can start adding commits to it. And that's fine. Those commits can all exist in the repository as sort of a list of commits one to the other. And we can have other commits that go in different directions, and we can have different branches that point at different states, and that can all be totally fine. Okay, this is all a little esoteric and has to do with like what often happens in like tracking versions in different states of the same library. So I just want to make sure that everyone kind of understands, at least abstractly, what I'm describing. Any questions? Okay. Okay, great. If I can find my mouse, I will clear that out. Okay, so what this is telling us here, head arrow main, this is telling us that this commit is the current head of the main branch. So if we, well, I haven't really talked about branches yet. So if we want to make a new branch, we can say git checkout. And now I'm going to make a branch that's going to be about my working on, I'm going to make a branch that's starting to work on our second recipe. So I'm going to say git checkout -b, which stands for make a new branch, new recipe. Okay. If I type ls, all the same files are here. Nothing's changed. All I've done is make a new branch that points to that same commit as the head. So this branch is currently identical to the main branch. Okay, whoops. Let's go ahead and use nano, and I'm going to open shortbread.txt to add our, or sorry, .md to add our second recipe here. Okay. Shortbread. Ingredients. Butter, sugar, flour, salt. That's pretty much it, right? Instructions. Mix together. Bake at 350 Fahrenheit for 45 minutes. Something like that. I'm going to go ahead and push Control O to write out that shortbread.md file, and then Control X. If I'm going a little fast and you don't get all that down, it's fine. We don't need a precise recipe for this demo or anything. All right. I'm going to go ahead and run git status. You can see that it says, okay, we've got, first of all, it says we're on branch new recipe instead of branch main. So it knows about that. And we see untracked files, shortbread.md. So I'm going to go ahead and git add shortbread.md. And then I'm going to do git commits. And I'm going to actually use a shortcut for git commit here, which is if you do -m, you can then put your commit message in single quotes after the -m and not have to edit it in nano if you want. So I'm going to put adding shortbread recipe like that. You can also use double quotes, single quotes, double quotes, doesn't matter. Okay, and that without opening up Nano to ask us for a commit message, we'll just use this little string here, adding shortbread recipe as the commit message. Okay. If I now type git log -- one line, notice that we have a new commit here for adding the shortbread recipe. And notice that here it says this is origin main or main. This is basically saying, look, this is where this commit is where the main branch is pointing right now. Up here we have head arrow new recipe, meaning this commit is where the new recipe branch is currently pointing. Okay, let's go ahead and git push. I forgot. Because we made a new branch, we need to tell Git that it's going to create a new branch up on GitHub when we push to it. So we say git push -- set upstream origin, and I'll unpack this in just a second. Okay, so we're only going to have to run it this way once. We just need to tell Git that this new branch recipe goes in the new, this new recipe branch goes in the new recipe branch on GitHub. So github.com has this repository, but it doesn't have a branch. It only has a main branch so far. We haven't synced anything to it. So we're going to git push, and in the process, set our upstream branch to be origin new recipe. Origin in this case just stands for our repository. It's just shorthand for our repository up on GitHub. Okay, when we run that, it tells us it's making a new branch. All right, so let's go over to our github.com again. And I want to go back to the main page for the cookbook repository. So I'm going to click this cookbook 2 up here. Now you notice that it says right here at the top, new recipe had recent pushes 16 seconds ago. It's telling us that someone just pushed some new stuff to this other branch in GitHub. We're not going to talk about pull requests in this session, I don't think, but it's sort of pull requests are a way of syncing information between different repositories or between different copies of repositories. Very useful for when you're collaborating with people, but we probably won't get to that today, I don't think. Okay, now looking here, I see license, readme, and guacamole, but I don't see our shortbread recipe. Anyone have any idea? Anyone have any idea why?
It's in the 2 branches.
Exactly. There's a little button here says main, and that says that we're looking at the main branch right now. But if we click that, it now has a new recipe branch here. And if we click on new recipe, it shows us that shortbread.md right here. Okay. Let's see. So there's a couple more things I want to show you. Obviously, there's a lot to Git. We're not covering very much of it today, but we are covering the 95% of what you'll actually use. I just want to point out that on this website, you can also look at those commit logs and things, and there's actually a lot of really great tools on the website for looking at the history of code. So we're going to look at that real quickly. You'll notice that there's this area right here that says 4 commits. And if we click on that, it'll show us our Git log in web page format, basically, where it's got all of these commit IDs over here, and it's got each of our commit messages. And there's all kinds of useful features in this interface. For example, let's suppose this is a really old repository and I've been working on it for years and there's hundreds of commits, and I want to go back to see what the repository was like on a particular day. Well, this is telling us these commits were all today. If these had been across multiple days, they would be broken up by day. And I could go to whatever day I wanted to look at. Let's suppose this commit in particular. I want to see the repository and what it looked like right after this commit. You can click this little angle brackets button, and it will take you to the repository at that point in time. So this is exactly what this repository was like if you rewind the commits back to that point. And I suspect that this is before I added mash it up with a fork, so this is just mash it up here. And we can go back and look at that. We can check it out. We can make a copy of it. So this is very useful for oh geez, we introduced a bug somewhere down the line. We don't know where or when. We need to go back and find the code when it still worked. That kind of problem. Very common. Any questions about any of that? Okay.
Yeah, and it saves indefinitely, or it erases after a time?
It saves forever. You can delete things out of Git repositories, but it's hard. It's deliberately hard, in part because suppose we're collaborating on a repository and I've cloned it and you've cloned it and we've all got our own copies of the repository. And then I delete some stuff out of it and I sync that up to GitHub. Suddenly, when you try to go sync, you've got commits that it doesn't know about because they've been deleted. And so if you delete things out of GitHub repositories, it creates a lot of problems. And so you're kind of never supposed to do that. Now, that isn't to say that you can't delete files. And I'll show you that right now. I'm kind of using two definitions of delete here. So suppose I accidentally commit my password in a file. If I accidentally commit my password, I need that off the internet. I need to scrub it out entirely. There are ways to actually delete things out of the history that Git keeps track of for that exact situation. But if you find yourself in that situation, come talk to us. We'll show you how to do it. It's something you should generally never do for the kind of reason I mentioned earlier. But let's suppose that we're working here. We decide that, okay, that shortbread recipe wasn't that great. We're going to get rid of it and we're going to try something else. I just want to get rid of the shortbread recipe. I don't care if it's in the history. I just want to make sure that when I clone the repository, it's not one of the files that's in the repository right now. So for that, I can actually just type git rm shortbread.md. And then if I type git status, it says, look, you've deleted this file. That's to be committed. So, and you notice that when we did git rm, it kind of automatically added it. We didn't have to add that because we're deleting it. So we're going to go ahead and say git commit, deleting. And here I'm going to use the git commit -m again to delete the shortbread recipe as my message here. Okay. And now if I git push, it'll go sync that up to GitHub. And if I come back over to GitHub and go back to the cookbook 2, now, of course, this is the main branch, so we wouldn't expect to see shortbread here. But if we go to the new recipes branch, you can now see that shortbread is gone. So it's not part of the tracked files in the repository anymore. But if we go to the commit history, we can still go back and find the shortbread recipe by browsing the repository before we deleted it. And here we can find shortbread.md. Okay. Any questions? Yeah.
So in terminal right now, we're still.
Yeah. Great question. So the question was in the terminal, we're still on the new branch we created. How do we go back to the main branch? I believe you just type git branch main. Oh, no, git checkout main. Sorry, git checkout main. Yes. Yeah, and now that you have both branches, you can just switch back and forth with git checkout. Yeah, and by the way, when you run that git checkout, it will automatically update the files locally. Now it's in general, Git is pretty smart. If you've been editing a file, it's not going to change the file you've edited. It won't clobber your changes in order to put the original file back or anything like that. And I would say that as a general rule, Git is very smart and conservative about not clobbering changes you've made. So it's pretty hard. I mean, it's definitely not impossible, but it's pretty hard to type a git command where you've been editing a file, and after running the git command, all the changes you made are gone because it's checked out some older version or something like that. It'll almost always be like, oh, wait a minute, I can see there are changes here, and I don't want to just overwrite them, and we'll prompt you or something like that. So in general, you don't have to worry too much about that. Okay, let's see. I wanted to show you how to use git diff. We still got about 15 minutes, so I think we got time. Okay, so let's look at git status. I'm currently on the main branch. That's fine. I think we can work on the main branch for now. Okay, so let's go ahead and I'm going to start by running nano readme.md. We're going to add a new recipe to the table of contents first. I'm going to come down here and say two. I don't know, what should the next recipe be? I already did shortbread. Okay, we're going to do, no, that's too complicated. We'll do vegetable soup. Okay. So I'm adding that. I'm going to push Control O, save this out, Control X to exit. Okay. Now we can type get status, and it tells us we've modified the README file. But we can also see what we've changed. So you can type a command get diff. Diff is actually a Linux command by itself. You can use it to compare two different files, and it'll tell you what lines are different between them. And pretty much that's what get diff does. It'll look through your whole repository and tell you what's different from the state that you last were at and the current state of the files. So if I run get diff, it basically says, look, in this README file, you have a change right here. You've added this line vegetable soup. Now, if we had instead like deleted this line, instead of adding this vegetable soup line, we wouldn't see this vegetable soup line. Instead, we would see a red table of contents line with a little minus in front of it. So this is a way to very easily see kind of what changes you've made to your repository. You can also ask for a get diff of just a particular file. So get diff by itself will show you the changes to every file in your repository. But if you want to just look at a particular file, you can do that as well. Okay, that's a really useful tool. I won't talk about it a whole lot more right now. Yeah.
I don't grasp the difference between git add and git commit.
Yeah, great question. So git commit, the whole point of git commit is you've made some changes and you want them to go permanently into the repository. So once you've git committed something, that's the point. After that, you don't want to delete it permanently. You instead can git remove it to have it come out of like the head of the repository. But once you git committed something, it's there permanently. Git add is about putting things in the staging area. Now the staging area is this kind of weird concept. If you're just working on one file at a time, you would almost never need a staging area. But the idea behind the staging area is you may edit multiple files and you may want them all to be part of one change. So adding something to your library, adding some functionality to your library may require editing several files in the library, and you wouldn't want to check half of them in because then your library would be broken because it doesn't have the other half of the changes. So you want to check those all in as one big commit. So you add them all to the staging area, and then you use git commit to add everything in the staging area as a single commit. Otherwise, you'd have to commit each file one at a time, and someone could pull something that was halfway between the finished change. Does that make sense? Okay. Any other questions? Okay. Great. So
Can I ask a quick one?
Yeah, of course.
Yeah, sorry, just because it's 11 p.m. here in the UK and my brain is starting to get a bit slow. Can you just quickly go over the differences between a branch and a fork again?
Okay, I was going to talk about forks next, and we haven't actually mentioned them yet. So good segue.
Yeah, I just started thinking about that already and figured I don't really know what the difference is.
Yeah. So branches are within one repository. If in this recipes or this cookbook repository, I made a branch for adding our new recipe, and that's all within this one repository. Forks are between different users. So let's do an example. If you go to github.com, what I want all of you to do is just go to your browser tab and type out github.com/Noah Benson, all one word, /cookbook2. Whoops, I didn't get that right. And maybe Kelly can stick it in the Slack channel just to copy paste. Thank you. So go ahead and what you'll find is the page from my recipe book here. So this is, I made this a public repository so you can all look at it. Now, recall that if you tried to clone this repository, you wouldn't be allowed to because it's my repository. But what you can do is go up to this fork button and go ahead and just click that button. Now, if I click it, it's not going to work because this is my repository and I can't fork my own repository. But I'm just going to I'm just going to find like Pandas. I'm just going to go to the Pandas GitHub library and show you how to fork it. So if I click this fork button, it says create a new fork. If you click the fork button for my Cookbook 2 repository, you get something kind of like this. You can name it whatever you want. You could name it Noah Benson Cookbook as your version of it instead of Cookbook. I'm going to call this Pandas because I don't have a library called Pandas already. And basically, you can just come down here and click the create fork button. And all that does is it takes the repository you're forking and it makes an exact copy of that repository in your account. So now you have a repository with that name that's identical to their repository.
But then if,
yeah.
Sorry, but then if we've not been granted permission to use the original one, obviously, if we'd create a fork, then we'd actually be able to make changes. So how is that allowed then?
Well, because you're making changes to your local copy of it that has no effect on their copy of it. So this Pandas, you notice this is Noah Benson Pandas, not Pandas.
Right, yeah.
And so when I make changes to this, it doesn't have any effect on the Pandas library itself because the Pandas library comes from their account. But what this does mean is that, let's suppose, so the reason you might use a fork typically, and this is a very common kind of workflow in open source software development, is that I'm using Pandas, I've been using Pandas for years. I realize that there's some feature that it's missing. Like I really needed to be able to like sort things this particular way sometimes. I don't know what this is for Pandas, but suppose I've got some feature that I think I can add to Pandas. The people at Pandas don't know me, so they're not going to give me permission to just go edit their repository. But what I can do is I can fork their repository, and then I can make the changes in my copy. And then I can basically go to Pandas and say, hey, Pandas, I've made this really cool change. I'm going to send you a pull request, which is basically, I'm going to request that you pull from my fork of your repository and take the changes I've made into your repository. And they can review those changes and say, oh yeah, these are good changes. Even though we don't know this person, we can look at the changes and then we'll pull them in and make them part of the Pandas repository. If you want to edit open source software, that's typically how it's done, is by forking it and making a pull request. And I would just say in the last 5 minutes here, a really good way to get started with open source software is to do exactly that. And my suggestion is if you want to get started with open source software or get involved in a community, fork their repository and edit their documentation, even if you don't feel like you can edit their code. Editing their code may take a lot of, like you may need to understand their code really well. But almost every open source project needs help with documentation. They need people like us to go around and clean up the documentation and write examples and that kind of thing. They will love it if you go and send them pull requests for documentation. They'll put you on their authors list, all that kind of stuff. It's a really good way to get your feet wet and to practice with GitHub and pull requests and kind of get to be a little bit more known and to meet the people working on those repositories. So as far as kind of getting started with this kind of workflow for collaboratively editing packages on Git, that's a great place to start.
Right. So then obviously if something is a branch and not a fork, then you can contaminate it, because imagine we're working on 2 different branches and then I write a lot of awful code and that's the same repo. Then obviously the difference is that this will actually be on the original one. It's not going to be a fork, but it's going to be a branch. So if the code there is poor, then ideally you'd expect all collaborators to be able to read this and go over it to make sure that it's good quality.
Right. Yeah. Yeah. So that's part of what pull requests are about. And in fact, when you make a pull request, there's mechanisms in the GitHub website where they can review your code and write comments on it line by line and that kind of stuff. And there's a whole lot of tools built around this kind of problem.
Thank you.
Yep. Any other questions? I think we've got about 5 minutes left. So if there aren't questions, then let's see. What's the best thing for us to talk about that we haven't talked about yet? Well, I would say, so we've talked about branches and collaborators. We've looked at history a little bit.
How to resolve conflicts.
Yeah, okay. I think that probably is the next step. Okay, so here's the thing. I'm not sure we're going to get all the way through this, but we're going to try. So let's suppose two people are working on this cookbook together. I'm working on it and I've got some collaborator. So I'm going to start, right. So right now we haven't committed this change yet. So I'm just going to go ahead and commit that. So that's a local change just on this computer to this repository. So I'm going to commit, I'm going to say adding whole soup to index or to table of contents. Whoops, what happened? Oh, of course, I didn't get add. I have to get add readme.md, and then I can say git commit, adding vegetable soup to table of contents. Okay. Okay, so I've now made a change locally here. Now, let's suppose I have another collaborator I've added it to the collaborators list on this repository so they can clone it and they can make their own edits. To simulate that, I'm going to go over and make an edit in the browser. Now in this case, this is an edit from me instead of from someone else. But nonetheless, it sort of simulates two edits simultaneously. And I'm going to also open up the readme.md over here, and I'm going to edit it. And rather than adding vegetable soup as the second entry, I'm going to add shortbread again as the second entry over here. And I'm going to go ahead and commit that change. I'm going to say adding shortbread to table of contents. Okay, I'm going to commit that. This is all in the main branch. So now on github.com, there's commits that make this have guacamole and shortbread. But if I go back to my terminal here, and I cat the README here, I see guacamole and vegetable soup. So we have conflicting edits that we've now made here. So let's suppose I have this edit and I go ahead, I've committed it, so it's part of my permanent repository on my local machine. It hasn't been synced up to GitHub yet. Let's suppose I run git pull. Oh, okay. Diverging branches can't be fast forwarded. You need to either do one of these things. So what this is telling us is that it encountered this conflicting change and it didn't know how to handle it. Now, in some cases, Git is very smart and can figure out how to handle things. If the changes were to different files, depending on your Git settings, often Git will just do this all for you and you won't have to even worry about it. But we actually edited the same line in both files, or in both copies of the repository. So there's no way Git's going to know which one we actually wanted. It's the exact same line. It can't tell who has priority here. Okay, so what it's telling us here, now exactly what message you get here is going to depend a little bit on how you've configured Git. In our case, we configured it to only be able to use a certain very simple merging strategy. So it's telling us what to do. And I don't know that I really want to explain the difference between merging and rebasing. We don't really have time to get into this, but these are different ways that you can try to resolve this conflict. What we're going to do is just copy this git merge command and use it. So we're going to run that git merge, and what it says is conflict. There's a conflict in this README file. Automatic merging failed. So you need to fix this manually. Basically, that's what it's telling us. This happens all the time. It's not a big deal. It just means we need to go tell Git what we actually want the file to contain. So I'm going to go ahead and run nano readme.md to open up that README file. And you notice it's added a bunch of stuff here. It said, look, here's your current local head has this vegetable soup. And then it's got this big equal sign saying that's the end of your local head. But up when we tried to pull, we got this shortbread instead. So all this is doing, these less thans and greater thans and this equal, it's telling us what the conflict is right here. It's saying, pick this one or pick this one. All we need to do is edit this file so that it's however we want it to be when this conflict is finished resolving. So I'm just going to do something very simple. I'm going to come down here and I'm going to delete this line because that's just telling me where the issue is. I can delete all this. And looking at this, maybe I decide, oh, you know, we want both a shortbread and a vegetable soup recipe, so I'm just going to make this a 3. Or maybe I get rid of the shortbread line, or maybe I get rid of the vegetable soup line. Whatever is correct for your repository at this moment. The point is you just have to resolve that merge somehow for GitHub because GitHub can't do it itself. Does that make sense? Any questions about that? Oh, okay, great. So once I've done that, I'm going to push Control O to write this out. I'm going to push Control X to exit again. And I believe now if I type git status, it's going to tell me I'm in the middle of a merge. Yeah, in fact, it says your branch and origin may have diverged and you're working on this merge here. It says basically here in parentheses, fix your conflicts and run git commit, or if you want to abort altogether, you can run this other command. So we've fixed those conflicts now, so we're just going to run git commit. Okay, so it's reminding me that you need to add them before you run git commit, of course. So git add readme.md and then run git commit. And now it's bringing up this the editor for our commit message, and you notice that it's put in a commit message for us, which is basically that we're merging these two branches. And that I think is fine as a commit message, so I'm just going to push Control O to save this, and then Control X to exit out. And now it should all be fixed. And if we say git log, well, first of all, let's just cat the readme to make sure it's fixed. See, it's still fine there. If I say git log -- one line, you can see that we have all of our initial commits. We have the adding vegetable soup commit, we have the adding shortbread commit, and then we have our merge commit that actually fix those kind of back together. Now, of course, we still haven't run git push or anything. So if we go back to github.com, we're going to see that readme still doesn't have vegetable soup, but that's easy to fix. We can just go back to our terminal and git push. And since we've resolved that merge already, we don't need to resolve it again on this end. If we now update, we should see that we have vegetable soup and shortbread. Okay, so conflicts aren't really that big a deal. You just need to be able to go find the text where the actual conflict is and resolve it manually. It's really just a matter of resolving it manually and helping get out a little bit. That said, as you'll all realize probably next week while working with Git, it's very easy to get into weird states where Git is confused about your files or whatever. And don't be afraid of that. It's just part of the learning process. Come talk to us, we'll help you out. Worst case, actually, I don't know if I can find it real quick, but do you all know XKCD? Yeah, okay. There's a great. Let me make this bigger. Yeah, this kind of summarizes almost everyone's experience with Git at some point. At some point, you will probably just delete whatever you've got and make a new copy and then add the changes you know are right and then put it back in. That's fine. That happens all the time. But you know, the more you work with it, the easier it will get. All right. Any other questions? Otherwise, I think we can break for coffee. Okay, great. Thanks.